Hi Math 2 students. This is the first in two parts of your Friday videos, April 24th. And in this video, we're going to revisit word problems. Now that we've learned how to use logarithms to solve for the exponents, we can get a little more sophisticated in our word problems. So let's review real quick. Our exponential form is y is equal to a times a rate to the t or x power. And what we know is that if r is greater than 1, we have growth. And if r is in between 0 and 1, we have decay. So we need to review that. And let's also make a little note of this equation because it's essentially the same equation. But in this form of the equation, we split out the 1 plus r. So we can use percentages that aren't exactly doubling and tripling and so forth. We also should remember our compound interest formula because we're going to be combining everything now. And so we may need this. So let's remember what that looks like so we can refer back to it as we go through the problems that we have here in our worksheet. So there's an example here. It says, what is the account balance after 5 years if $2,500 is deposited in an account that pays 7.5% annual interest compounded monthly? So here's an application of our compound interest formula. So they're asking us to find the final balance, and they're saying our principal amount that we invested is $2,500, and we're being paid a rate of 7.5%. Remember, we always enter that percentage as a decimal, and we're compounding monthly, so we put a 12 in for n, and then 12 times 5 because we're investing for 5 years and we're compounding 12 times for each of those 5 years. So what I want to do is I want to evaluate this expression here, and the keystrokes are very important that we pay attention to order of operations. So I'm going to go through that. What I do is I put in 0.075 for the interest rate and I divide that by 12 and I just hit enter. And then I have to add 1 because, of course, we have to do what's inside our parentheses before we do anything else. And then I take that value and I take it to the 12 times 5 power. You can go ahead and just multiply in your head and take it to the 60th power if you want to. And that is the value of this piece of our equation. And then we need to turn around and multiply that times 2,500. And we get our answer is $3,633.24. So let's write that down right here. $3,633.24. So that's the answer to that problem. In the next example, we need to solve for an exponent. And I want to skip number A because I think it has a typo in it. And let's do number B first. Essentially what I'm being asked to solve for is x here, and it's in the exponent, so I know I'm going to need to get both of these into the form where I have a base of 2. But when I look at 82.1, I honestly don't know how to express that as a power of 2. So I'm going to rewrite this as a logarithm, and I'm going to say log base 2 of 82.1 is equal to x minus 4. And now notice I have solved for x, almost. If I added 4 to both sides of this equation, I would have solved for x. So let's go ahead and do that, but first I'm going to evaluate log base 2 of 82.1. So again, I'm going to go second 0, and then alpha and the divide button. And for some reason, my calculator wants me to hit that twice. And then I go back up to log base. My base is 2 right here of 82.1, and that value is 6.359. So I would just write x right here, 6.359 is equal to x minus 4. So we aren't quite solved for x. We need to add 4 to both sides. So I'm going to add 4 and get that x is equal to 10.359. And I'm just going to round that to 10.4. And that's the solution to my equation. So let's work C and D together. In this expression, I have to be careful to first divide both sides by 15 before I rewrite this as a logarithm. When you rewrite something as a logarithm, you want just that number taken to a power. So you have to isolate that piece. 15 divided by 15 is 1, and 48 divided by 15 is 3.2. So I have 18.3 to the x power, excuse me, is equal to 3.2. And now we can rewrite this as a logarithm. I would say log base 18.3, because that's the base of the thing that I'm exponentiating there. Base 18.3. The exponent always goes on the right-hand side, and then I'm taking the log of 3.2. So in this case, I'm going to need my calculator. I'm going to have to say, go to log base, second catalog, and then alpha, divide, and I go up to log base. And my base is 18 point, let's see, my base is 18.3, and the value that I'm taking the log of is 3.2, and I would get that x is equal to 0.4. So we would just round there. The last one is very similar to C in that I'm multiplying right here, and I've got to get rid of that multiplication before I can take the log. So I'm going to say this is 4 to the 2x power, and that is equal to 81 divided by 3, which is 27. And again, I can't rewrite 27 as some kind of base of 4. And so because I can't, I'm going to rewrite this as log base 4 of 27 is equal to 2x. And so I would use my calculator to evaluate log base 4 of 27. So I'm going to go to my catalog and find log base. And the base I want to put in is 4, and the value I'm taking the log of is 27. So we would get that 2.4, let's go ahead and round to the tenths, is equal to 2x. So I would need to divide both sides by 2 and get 1.18 is equal to x. Well, actually, if I had rounded, I would say 2.4 divided by 2, and I would get 1.2 is equal to x. So that is how we use logs to solve for things that we have in our exponent. Ultimately, what we want to do is we want to be able to do this with word problems, real-life word problems. So that will be the topic of your Friday video series, part 2.